Welcome to this introductory video about digital engineering. This video will introduce the topic of government reference architectures, or shortened to GRA. The topics covered in this video will be 1. What is a government reference architecture? 2. What is the purpose of a government reference architecture and what are their benefits? And 3. How will a program use a government reference architecture during systems acquisition process? The last topic might be the most important to most of you, but we'll address the other two first. What is not going to be discussed in this video is how to build a GRA, how to get a GRA approved for use across the Air Force and Space Force enterprises, and how do you use the library of GRAs to best suit your program. More on the government reference architecture library later, but future videos will cover these topics to provide the details needed to implement the GRAs to make best use of digital engineering. So, to start, what is a government reference architecture? Let's begin with a definition of a reference architecture. The first definition is taken from DoD Reference Architecture Description, published in June of 2010. This definition has also been repeated in the Air Force Data Services Reference Architecture, published in March 2019. These documents state that a reference architecture is an authoritative source of information about a specific subject area that guides and constrains the instances of multiple architectures and solutions. The key words that appear in this definition are guide and constrain. But it also states that a reference architecture should be applied to multiple architectures, and this is where the benefits of a reference architecture are derived, which will be later discussed in this video. Another definition for a reference architecture was taken from Wikipedia, which states a reference architecture provides a template solution for an architecture for a particular domain. It also provides a common vocabulary with which to discuss the implementation, often with the aim to stress commonality. Here the keywords are template solution and for a particular domain, as well as to aim to stress commonality. There are many examples of such architectures, usually defined in a military standard. To accomplish this standardization, like MIL Standard 1553 for multiplex data bus structures for data exchange used on aircraft and space vehicles. Based on these definitions, we can begin to build a picture of what a government reference architecture is. First, let's add the government part to the definition. Now the definition can simply be expanded to say that a GRA is a reference architecture provided by the government to support the acquisition process using attributes to guide and constrain the system design, manufacture, and sustainment. Also, the term government reference model can be used since the architecture can be built by models, and the information provided by the government might not just be architecture, but include bot models for business processes, system performance, interface standards, and so on. The GRA would be used like the work breakdown structures, WBSs, that are implemented in contracts today. The WBS provides a format for which the contractor will fill in when responding to how the work to build a system will be organized, containing the engineering, design, and manufacturing tasks, as well as the cost and schedule for these tasks. Working in the same way, the government reference architecture will provide details for system performance requirements, intended uses, interface, standards, verification methods, and certification process. The contractor will be given a GRA and fill in the details to be able to design and manufacture the systems based on the guidance and constraints in that reference architecture. So, here's a simple model to explain what a reference architecture does. This model shows that a reference architecture is used to guide and constrain the development of a solution architecture, but is not specific to one system, which is shown as the reference architecture is outside the system boundary in the diagram. The solution architecture is the system being developed by the program office or such organization using an acquisition process. The solution architecture is an actual design of the system, aka the product baseline, and it can be used as the basis for the digital twin. To state it simply, the government reference architecture is used as a template for a system design to provide guidance on how to model specific areas of the design with rules or constraints that must be followed. As an example, a government reference architecture for an automobile provides guidance on safety and efficiency, but not style. It also constrains other areas such as width. A vehicle cannot be wider than 8 feet, else it won't fit in the lanes, and special permits and operational restrictions will be needed to operate the vehicle. So this leads us to the purpose of a GRA. The GRA serves several purposes based on the guide and constraint definition. First, the GRA provides a common language for the various stakeholders in the domains that the system will operate. This is often referred to as an ontology. Second, it provides a consistency in implementation of technology to solve problems. This is normally through model reuse, where, like code reuse, once a model is built to show a certain architecture to solve a problem, say airworthiness, other programs can reuse this model to solve the same problem. Third, the GRA supports the validation of solutions against a proven architecture. This is performed mainly with enterprise architectures where a system links to other systems. The interfaces at those boundaries would be checked against the reference architecture, especially if the other systems already exist. Fourth, the GRA encourages adherence to common standard specification and modeling patterns. This would be documented in style guides that would be part of the GRA to ensure the models will be compatible. And fifth, the GRA can be defined the business processes, regulatory compliance criteria, and technical design reviews and verification procedures. This is built-in verification and accreditation processes for test and evaluation within the reference architecture. The benefits of using a government reference architecture during acquisition include: first, increasing the speed of acquisition by standardizing enterprise requirements and interfaces. For example, with a GPS receiver, once the model is built to specify how the signals are sent, other programs can use this model to specify how a receiver must process them. Each program does not have to build this model themselves. Next, the GRA provides a starting point for the basic structure of a system, or define the modular architecture of a system. Of course, the architecture should be based on open standards to implement the MOSA concept, but the GRA can be used to communicate the preferred structure for the system to the bidding contractors. Third, the GRA removes ambiguity between programs by defining the standard processes and deliverables for the government reviews and certifications. For processes like airworthiness, the exact steps of the artifacts necessary for the approval can be provided for a clear understanding by the program and the bidding contractors to determine the cost and schedule. Fourth, the GRA bounds the solution space to decrease requirements creep and define the needed capabilities and performance using mission threads and models. Lots of new terms there, but basically it means the system, its purpose, and the necessary certification processes are known, reducing cost and schedule risk. Finally, the GRA sets the standards for model-based systems engineering, so proposals can be compared against a common framework for effectiveness. This could be very useful during the source selection and the development process to evaluate the designs. To explain how the government reference architecture will be used by the programs during acquisition, let's put together a diagram to show how all the pieces work together. At the beginning, the architecture of the system is built based on the requirements coming in from several sources, including the warfighter needs defined in mission threads, the threats to the system, the overarching enterprise architectures, and any new technology developments. All these requirements are then analyzed as trade-offs for affordability versus mission effectiveness, and to determine programmatic risk. This analysis should be accomplished using model-based systems engineering, or MBSE, by building the models for the system and details for the interfaces with existing systems. This work will be significantly accelerated by reusing GRAs from the reference library for existing systems and the enterprise modeling standards. By putting together these existing models with the specific architecture and models for the system to be created, a program government reference architecture describes the details for the system to be produced by this acquisition and will be the basis for the contract. The RFP package, with its requirements, specifications, interfaces, and standards, can quickly be created from the model, or the model itself can be the handoff to the selected contractor as the GRA to begin building the system. This is the focus of the GRA, to build a comprehensive request for proposal, RFP, for the contractors to bid against, and then successfully build the system. The GRA will continue to guide the acquisition by providing constraints for the design, as well as defining processes for verification, validation, and certification. As the standards, interfaces, and processes change, the GRA will be used to evaluate and record the effects on the system. A program GRA could change over the lifecycle as the inputs change that were used to create the GRA at the beginning of this process. This video covered the introductory aspects of a government reference architecture. It has defined the term, shown how a GRA is used, described the purpose and benefits, and finally explained how a GRA, along with standards and a reference library, can speed up acquisition. To learn more, look for training material on building a GRA and using the reference library on the digital guide site.